IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about application architectures and microservices. It's available for download at thenewstack.io. All right, Alex Williams, the New Stack, here at Dockercon with Jason McGee. Jason, how are you?
I'm doing great, thanks.
And Jason, tell us a little bit about yourself for the folks in the audience who are new to this new world or just trying to get their own heads around all the people in play. There's
Sure.
so many.
There are many. So my role is I'm the CTO for Cloud Services at IBM. So I kind of drive our technical strategy around containers and microservices and cloud services in general, trying to build out the platform that IBM's providing in Bluemix and helping developers build apps and run apps.
One of the topics that we're exploring in this second book on our series on Docker container ecosystem is about application architectures and microservices. And the more I talk to people, the more I hear them say that microservices is a concept. It's mostly that. It's not anything in particular.
Right.
So I'm trying to understand what are some of the major themes around microservices, right, that are emerging. And there's a historical perspective there, and I think you have to take that into consideration. I'm curious on what your historical perspective is on this microservices movement, and then perhaps we can get into discuss from that some of the themes that we're seeing.
Yeah, sure. So I think, it's interesting. I think a lot of people talk about microservices as a technology, when in reality, I think it's more about people and how people work together. And I think for a number of years, development teams have been kind of struggling through how do they deal with the kind of increasing speed pressures, right, delivery pressures that they have. Right. It's interesting. A number of years ago, like SOA was a big movement within the software industry, and I think SOA, in some sense, you could view as a precursor to what's going on with microservices, in the sense that the idea was like, well, how do I take the applications I'm building, break it up into a set of kind of independent, well-defined services that can interact with each other, and use that as a mechanism to kind of organize teams and spread spread the load across the team. And I think the thing that SOA missed was it was very focused on what's the interface to something, but didn't really encompass the whole delivery life cycle around something.
Okay, so it looked at the interface more than anything. How so?
But it really focused on, okay, let me define how I talk to the service.
Right.
It made no particular assumptions about whether that service had an independent life cycle, how it was deployed, what technology was used to build it, how the team was organized around it. All it really said was, I can decompose my world into standard things that I know how to talk to.
Right.
And so people got some benefit out of that, of course.
And that was really, a lot about that was like XML, for example.
Yeah, and at the time, of course, the technology was, let's do this all in XML instead of in proprietary binary formats. And so we have some common language to use to interact. And I think the fact that it missed the kind of rest of the life cycle prevented it from really achieving the full acceleration that you would want, because ultimately you need a mechanism to not only define how you talk to something, but to really break it out as its own piece that you can put a team around that owns that one piece, and free that team from having to coordinate with everybody else on what technology stack do we use? What version of that stack do we use? When do we do deployments? What is our deployment model? I mean, a lot of those problems weren't really tackled, I think, in that era. And I think if you look at what's going on now, under the banner of microservices, I think what you're seeing is that interface idea is still there. The technologies have changed. It's HTTP and REST and JSON, not XML, predominantly, although there's also an interesting kind of event and message-oriented flavor of microservices happening. But you also see the team being organized now, so you get a small team that's kind of responsible for a service. The life cycle of that service is owned by that team. They can update it whenever they want to. The technology is more open-ended. So you're really seeing them organize around an independent unit throughout its whole life cycle. And that's, I think, the empowering thing about microservices is that you can give 5 or 10 or 15 people responsibility for a function, and they can kind of manage that function throughout its life cycle and update it whenever they need to without having to coordinate with the rest of the world.
So with that era of the XML, the way you describe things, and then what happened then to the rest of the life cycle management process?
Oh, then?
Yeah.
I think it varied, but for the most part, it kept the kind of approaches of the time, which was a more monolithic kind of delivery model. That didn't really change. So people took the kind of monolithic system they had, they decomposed it into interfaces with well-defined XML boundaries and over HTTP. But the actual delivery model, the team structure, the way that it updates, all of that stayed in many cases in a more monolithic model. Right?
Yeah.
And everyone was still like, we're building this on Java, and we're going to use this stack with this version, and we're going to coordinate all of that. But they didn't really change the delivery model. And therefore, they saw some reuse benefit maybe out of the service boundary, but they didn't see the kind of full acceleration that you would get if you could actually decouple the teams from each other. I mean, that's what I think you're really trying to do with microservices is take a big complex problem and break it up into units that are truly independent. Like the interface provides a contract about how you're going to talk to me so that the thing can continue to work. But you've decoupled the kind of life cycle so that people can operate in smaller groups with less coordination. And therefore respond more quickly and go faster.
Yeah, in that era, it was like big teams and getting together in a big room and getting the whiteboard out and saying how this is going to work and how we're going to fit the networking.
Big kind of tops-down architecture.
Yeah,
absolutely. And so I think that's, to me anyway, that's part of the transition I see happening is that you got to think about this a little bit more holistically. And I think there's enabling technology along the way. Like the emergence of cloud and cloud platforms, I think provides a big enabler for things like microservices because it standardizes some of the underlying infrastructure concepts so that teams can operate more independently of each other.
Right. And what seemed to come out of that was rethinking on delivery, which I think you pick up on, right? Yeah. So we saw then the emergence of REST-based APIs.
Yes.
And the REST-based APIs, I think, were most symbolic, for me at least, with Twitter, right? Yeah. Twitter introduced itself, and it didn't really seem like much of a technology, right? 140 characters, it seemed just like another kind of messaging service, right?
Yeah.
But it was more about the APIs than anything else because they had a very open API, infrastructure. So suddenly, there were like developers doing all kinds of things that they couldn't do, for instance, in applications that had been introduced, any time before that.
Yeah.
So that seems like it was a noteworthy time in itself.
I agree, and I think also REST helped decouple the implementation decisions. So, it really did provide even more than XML, I think, REST and JSON provided a way for those services to talk to each other independent of any decisions that team made about how to implement that service, right? And so there was very light kind of technical dependencies between things that made it very easy to mix and match and bring in something else. And of course, you also inherited the kind of web scaling model with load balancing HTTP requests and stuff, which helped with scale and other concerns.
And it seemed like we started to see this, and also like the democratization of programming languages too.
Yes, absolutely, right. Yeah, I think this model allowed you to get to more of a fit-for-purpose perspective on things like languages. Use the language that made sense for the task, or frankly, use the language that made sense for the team of people involved. Right. Instead of this kind of everyone kind of agrees on a certain stack. Right. I mean, I think the reality is within organizations, there tends to still be a dominance of one technology or language because that's the heritage or skill set of the team. Right. But on the macro sense, you get to mix in new things or bring in new things as appropriate. Maybe it's all written in C# or something, and then you have some new component coming in Node, and you can do that because the way the system is put together.
So it speaks to that polyglot environment that the .cloud actually tried to develop themselves, and they actually have one of those first platforms to do that. Right. It also seemed like there's an interesting history of like the compute available, right? There became a tremendous amount of compute that developers could access more than ever before. Now today, it almost seems limitless, doesn't it?
Right, it does, yeah.
And
For the practical developer, it is effectively a limitless environment.
Right. And is that how do you see that reflected in the decoupling and in terms of current freedoms that developers have to build out services?
Maybe again, it's like one of those indirect things that says, okay, if you're going to free these teams to work independently and they're going to build all these services, then that has an implication on the infrastructure underneath. And so if the infrastructure had stayed a more traditional finite pool of infrastructure resource, then you wind up with this kind of big funnel, I think, of all these teams trying to work independently who all ultimately have to coalesce on these 5 servers or something, right? In which case, a recoordination winds up happening. But if you have what's the funnel kind of going the other way, that says I have all these teams who are deploying onto what feels like an infinite resource pool, then they can still be independent of each other. Like if I need to spin up 50 of these and you need to spin up 10 of those, well, that's fine. We can do that because we have this infinite compute resource we can use instead of our 52 teams all have to land on this one big server, right?
Exactly.
And so I do think those kind of cloud resource notions really helped enable. It's interesting how kind of all these trends came together in a certain way to enable this way of thinking about how to build.
I was going to say, there's so many other things we could talk about, right? And that fit into this context. The introduction of the iPhone, right? The new capabilities to use new frameworks, right, to develop applications. You could talk about the advent of social networks and made us think a little bit differently about sharing technologies.
Yeah, absolutely.
So today, though, now we are seeing this Docker and container ecosystem emerge, and what are some of the main themes that you think about today that are shaping the concepts about microservices that relate to Docker and container ecosystem?
So I think one of the things I think is really starting to shape it is a reflection of the fundamental trade-off that microservices forces, which is, often in technology, every good thing has a downside, it has a trade-off. And I think if you look at microservices and the organizational model that it promotes with kind of decomposition and loosely coupled teams, the trade-off, the negative trade-off, if you will, is a great increase in complexity of operations. You have a much more complex operating environment. In fact, there's a number of interesting examples where customers maybe took an existing monolithic application, they broke it into 300 microservices. So maybe originally they had a big monolith and they were running 10 or 15 instances in a cluster, and now they have 300 microservices, each of them clustered with load balancers, and you wind up with 1,000 moving parts for what used to be 10. Right? Yeah. That's a heck of a lot more complex operational model, right? And that's really the trade-off you've made. So I can go faster, I get more loose coupling, the teams can work independently, we can update things, but the side effect is we just have a lot more stuff that we're managing. And so I think a lot of the maybe activity in the microservices space is really about, well, then what's the tools and management system you have to put around all these services to make that a practical thing to do.
Right.
And you see, containers absolutely play a role as kind of the fundamental kind of packaging and deployment model for the service implementation, but you're already seeing the emergence of all the things around it, whether it's service discovery or intelligent proxies or, deployment control tools that do A/B testing and red black. And, you need these kind of foundation of capabilities wrapped around it. And how you achieve that is where I think you see all the variation. Lots of people have built their own frameworks. People are starting to have common frameworks that are being built. But you see all this diversity happening in the kind of management around this complex operational environment.
What are some of the ways that you're seeing customers manage that diversity?
I think they're, first off, trying to kind of understand how they want to factor their application and what approaches do they want to take for kind of wiring everything together and for visibility. I mean, I think the two fundamental problems you have to solve is how do all the services find each other, right? So they're trying to manage complexity by instituting some standardized approach for them to find each other, which is essentially service discovery. But there's millions of ways to accomplish service discovery, but they all kind of recognize they need that. And then there's the kind of monitoring and visibility thing, which is how do I actually understand what's going on? I actually think that's, in a lot of ways, the most interesting space right now in microservices. How do I actually get visibility into what the heck is happening in this complex network of services? Because at the end of the day, from a customer perspective, it's if I oversimplify, I have an app that I'm using. Behind the scenes, that thing is 100 services, but you don't know that. You just see the app. And if it doesn't work, some poor soul has to go figure out what's going on.
It becomes a mapping project.
Yeah, a little bit. Where's the problem? And there's so many, like any system with more moving parts, there's more ways for it to fail, right?
And you can't find it, you can't find it by looking almost like at a sea of numbers. You have to find other ways to view it.
Yeah, some of it the system has to just deal with on its own. So that's why I think you see new kind of resiliency models, the rise of immutable images as a deployment model. Like, we're not going to go change code because that would make it impossible for us to figure out what's going on. You need a new breed of kind of instrumentation and monitoring tools that can kind of understand and actually dynamically build the relationship, right, between the services. You can't take a traditional kind of, there's no way a human can kind of map ultimately how everyone's talking to everyone. So I think some of it the systems have to solve on their own. Some you need these new tools to give you that visibility that you need. But I think that's a real problem that has to be solved for microservices to gain adoption.
It speaks to the the need to think about the ecosystem much more holistically, doesn't it?
Yeah, it does. I mean, I think if you looked at especially in the container space, you look at the container kind of runtime, and if you zoom out a little bit, you say, how do I actually use this in a microservices style of application? You quickly run into all of these other issues, and how am I going to solve them? And I think it's interesting. I think a lot of the most well-known examples of microservices in some of the born on the web properties, what those teams did was build their own frameworks to solve all these problems, right? And so the first wave of technology around supporting the idea of microservices was the emergence of these in-house built frameworks that were optimized for one team to solve their problem. The second wave which is probably ongoing now, is other people reusing those frameworks. So the kind of next tier of adopters who are saying, well, maybe I can reuse somebody else's framework to help me manage this problem. And I think the third wave is going to be how do we standardize, in a sense, not kind of formal documentation standards, but de facto standardize through open communities some of the approaches from a programming model standpoint, and then deliver that stuff as services, right? So that you don't trade off like, oh, I want microservices, so the first thing I have to do is deploy and manage all of these other components to help me do microservices.
I see. So through organizations like OCI and
or CNCF or something like that, maybe we'll all agree on, well, here's how you do service discovery, for example. I mean, because the reality is some of these concepts bleed into the app programming model, right? Service discovery is a great example. I mean, one approach is I could use DNS.
Right.
Another approach is I could do an explicit REST API call to look something up.
Or use etcd.
Right, or I could use a store like etcd and go look that up. Or I can do sidecar proxies, like all my services live at localhost / some logical name, and magic happens to route me there. There's a number of different approaches, but that actually impacts the app. Like, the developer has to know, like, do I just look up my service name, or do I do this API call, or do I go through this special path? It actually bleeds into how the application talks to each other.
That's difficult.
Right? And so I think there's a real need for us to agree on the approach, right? We can have different implementations behind the approach, but from a programming model standpoint, we have to start to agree on approaches. Otherwise, you get what we have now, I think, which is your app, your microservices app from a technology perspective is bound to a framework choice about how you chose to put the whole system together. Right, and if you move it somewhere else, hey, it's not going to work in that environment.
Speaks to the need for semantics in some respects with these systems, because they're so complex now.
Yes, they are, absolutely. And I think it's just the state of where we are with the kind of adoption of these technologies, but there's just a lot of diversity, right? It's actually one of the main things I would like to see happen in the context of the Cloud Native Computing Foundation, is that we start to agree on, OCI, I think, provides us the base primitives for what is a container.
Right.
CNCF has the promise of being a place where we can all start to talk about that next layer of issues. How do we do discovery? How do we do routing? Right? How do we do deployment control? Like, orchestration of workloads. Those things have to, at least the elements that bleed into the app have to start to get some consensus around them. Because otherwise, as a developer, you're kind of forced to pick a framework first and then implement based on your framework choice. And that's really the world of 15 years ago.
Yeah, and it gets into kind of a whole kind of cycle of rip and replace.
Right.
Which is time consuming and disruptive.
And then you get into an evolutionary problem too, which is like, okay, you pick something and then 2 years from now, there's something better. And
how can you make those more, how can you make these things more loosely coupled then so you can interchange these components more effectively?
Well, that's why I think that the best approaches are ones that build upon concepts that we already had. So like personally, I like the kind of, let's say for service discovery, I like the approaches that are based on something like DNS or routing, which is from a programming model perspective, there's not an API. You just talk to your service using a normal URL, for example. And the framework you're running in, the system you're running in is smart enough to know that, okay, that host name or that URL maps to this logical service. So you don't have to program to it per se, right? But there's other approaches that are certainly prevalent. Right? I mean, there's Netflix Ribbon Eureka is a great example. It says, okay, their system is a client-side library that talks to service discovery, which means from a programming model standpoint, you have to program to Ribbon, right? Change how you make calls to downstream services. Right. There's a lot of power in that model, but you have to adopt that programming model. Right. Whereas, you look at, let's say, what the Docker guys are doing with Swarm and libnetwork, they have more of a DNS-based model. They put an entry in etc hosts, essentially. So you can just look up your peer service by its logical name as a DNS call. That's much better from a programming model standpoint, but it has its negatives, which is, well, DNS has, you don't have as much explicit control over how routing happens. It's harder to do versioning and rollouts that way. And frankly, there's a lot of bad behavior in software around DNS. Like people don't respect cache timeouts and they cache DNS resolution, and therefore you make an update and the client doesn't see it because it didn't bother to look it up again. And so, but it's that space that I think is just an example of one of the technology spaces that has to go get kind of worked through to understand what's the right balance of approach that a developer can take. And then we can all innovate on the implementations behind that.
What's the IBM thinking about it?
Right now, we are doing a couple of things. We're building service discovery as services in cloud. So you don't have to kind of run that infrastructure. From an interface perspective, we're doing two things. There's a REST API, of course, which I view as the kind of base building block. What we're probably going to do is do a URL kind of route path on the side. So you'll just do a lookup, a URL call to a local proxy that's kind of responsible for routing, which is a little bit different than straight DNS. So straight DNS, you get back an endpoint, which is the service you're going to go talk to. With this approach, the DNS resolution, which is kind of how you start in the programming model, always resolves to a local proxy. And the proxy is smart enough to talk to the discovery server and figure out where to send that request in a very dynamic fashion. So it's a blend of the two models, right? From a programming model standpoint, it's just like HTTP get this URL, which happens to be, my catalog service or whatever it is. And we kind of can use things like containers to inject some magic on the side. So you can do things like sidecars, for example. I can deploy a microservice helper function next to your container app in its own container and handle the routing and traffic through the side.
So why are you taking this approach?
Because of the way the programming model gets impacted. So now I have essentially a standard programming model. I don't have a specific language binding. I can use kind of regular REST calls. I don't have the DNS resolution issues because I'm always mapping to something that's stable and happens to be local. And then we can inject the magic in the interaction between that local proxy and the discovery server to handle any advanced kind of routing and deployment scenarios that are needed. Right. So that's where we are now. But I think collectively as an industry, we don't have to agree on all the backends, but we have to agree on kind of some standard models that developers can follow.
What are some of the basics you need to agree upon?
I think we have to agree on the thing we just talked about. I think we have to say discovery is probably the biggest one because it's the one that impacts the programming model. Schedulers, not so much. Orchestration and composition languages. Mm-hmm. So how do you define what a service is? How do you define the collection of things that you want to deploy together? Mm-hmm. I really think it would be useful if we all tried to agree on a definition of service We don't really have a standard view of what makes something a service. We use the word a lot, but I don't think we've all agreed. We have containers, but we don't have really service. Kubernetes, for example, has a definition of service, which is kind of an endpoint to a replication controller, which is a collection of instances of some container, or pod, actually, in Kubernetes, which is a collection of related containers. That's close. I think it's actually quite close. But we need to kind of agree, because as a developer, I probably want to build a service, and a service has some compute, probably a container, could be something else, but probably a container image. I want to run multiple instances of that. I want the number of instances to be based on demand on the service. I want to publish some well-known endpoint that people can talk to me on. I need a load balancer somewhere that knows about me, that can decide how to do distribution of traffic, that can handle, deployment, red, black, or do canary testing, that kind of stuff. I want to kind of define that, be able to program to that. I need some orchestration system that knows how to stand that whole thing up, right? That definition of that kind of box, which is a service, I think would be a construct we could define in some place like CNCF that developers could rally around. I'll define my service. I can run my service on my laptop. I can run my service in an orchestration system like Swarm or Kubernetes. It can stand my service up for me and manage it, but I don't really have to know about the orchestration system, and they don't have to know a heck of a lot about what's inside the boundary of the service. So I think there's ideas like that have to go get fleshed out.
So I'm thinking through like Kubernetes, for example, or Swarm, for example, then the idea then being that there's some standardization, at least on some of the major, foundations of those technologies.
Yeah, absolutely. And I think, like I said, I think Kubernetes is probably has more of an opinion about this right now. I think if you look at things like Swarm and the Docker ecosystem, they're not quite there. I mean, they have the concept of the container. They have some of the concepts of merging in things like Compose. So Compose has the ability to scale a container. We've seen a number of demos this week where they've done that. But really, the system doesn't understand that thing is a group of related containers. That's just like run Docker run 6 times, right? And maybe they all start, maybe they don't all start. But there's no notion that that's a group and that you wanted it to be 6, and if one of them fails, it should go back to 6 on its own. You need some definition that says this is a service or group. And Docker doesn't really have that yet. They have the kind of basic constructs for remote container environments with Swarm, and they have some notion of application with Compose, right? So I think the Compose piece is quite interesting, but it doesn't really have all the constructs in it that you need yet. I'd like to see them come together, right? Because I think Kubernetes has all of the concepts. Docker has, of course, great developer traction and mind share, and people really understand that technology. So you can bring them together in some interesting ways. Hopefully.
Yeah. The question then seems to be about almost like the intelligence in the system itself to be able to detect the containers and what they are and what they're supposed to do, right?
Yeah, there's some of that for sure, or some system that allows the environment to understand the relationships between things. Right?
What would that system be, for example? And we've touched on some of the things, but
there's a number of examples. We talked about the Kubernetes one. I mean, like in our system, in the IBM Container Service that we developed, we have the notion of a container group. A container group is a collection of like containers. It has a desired size, could have a min-max kind of concept, has an endpoint or a route that is kind of how that group gets exposed to the outside world. You can actually define that as an entity in the system. You say, I want to create a container group, not create a container. And I can put that policy around it, and the system will then manage that on your behalf. Right? So I can kind of deploy that. Now, the reality is that's something we've invented for containers. Google invented the concept of pods with Kubernetes. There's lots of these ideas floating around.
There's labels, right?
Yeah. There's labels as kind of a lightweight way to do that. Yeah. All of them impact the developer somewhere. I either have to call the group API or call the Kubernetes API or set up labels, and we can all like invent our own label taxonomies on how we use labels. All those work in their domain, but as a developer, ultimately I'm going to have to pick, and whatever I pick is going to lock me in on some levels to the fabric that I'm running in.
How about standardization around registries and such? Where there's so much activity around the registries themselves.
By registries, you mean like etcd kind of things, or you mean
like private registries, like
Docker registries?
Yeah.
Yeah, that's an interesting one. I mean, I think Most people are actually using the standard implementation of the registry from the Docker project to run them, with the underpinnings of Docker Hub, let's put it that way. What I think is interesting is there's not really a federation model. You know, the registry model we have right now is there's a default central master, which is public Docker Hub, and then there is specified registries, which that kind of bleed into the name of the image and everything, right? So from a pure technology standpoint, I think it's good in the sense that we all kind of are using some derivative of the same basic registry implementation, and therefore the API that we talk to registries is common. I think what's missing is like what happened in Linux with mirrors and federation of package repositories and stuff. I think you need something in that spirit in the Docker world, so all these containers can be distributed from the providers, right, and not kind of come back to a central place.
Right.
And I think that's going to have to happen if you look at, one of the, maybe less obvious implications is that there's not very much commercial software available in public Docker Hub.
No.
Right? It's all open source technology, which is great. I mean, obviously a lot we can do there, but at some point, we're going to have to cross a line where how do we actually distribute commercial software as well? Right. Because people want to get the value of containers for...
They want to pay for that service.
For software that isn't fundamentally, is fundamentally commercial software.
Yeah.
And distribution from registries is part of that problem space, right?
Yeah. I guess, one of the things I wanted to just, finish up with are some of the other themes that we're seeing. I mean, there seems to be a real deeper movement around continuous integration and continuous delivery.
Yes.
How do you perceive that? What are you seeing from customers, for example? What are they saying about it? Because it seems like a kind of almost like that incremental step towards building out microservices, the ability to understand how to iterate.
Yeah, I agree with that. That it's certainly, I think, a prerequisite or a capability you have to get to microservices. Some customers, I agree with you, are kind of trying to go there first as they work their way towards microservices. Actually, I think it's easier with microservices just by virtue of the fact that the things you're now trying to continuously deliver one, you have to do it, and two, the scope of each thing you're delivering tends to be smaller and more contained, and therefore it's actually easier to get a CI/CD pipeline truly in place and working for an individual microservice than it is for some big multi-team coordinated monolith that you're trying to deploy. But whatever path they take, you have to get there. I think that is absolutely a prerequisite, both to the pace that you're trying to achieve with microservices and to the complexity, right? And if you're also managing, take immutable images. If part of the way you're managing the complexity is by ensuring that every container for a given service is identical by never changing a running instance, then you kind of have to have a CI/CD pipeline that builds that images and deploys it. If you have people doing that, then you're going to get drift that's going to cause problems, right?
Yeah.
So you kind of have to have that pipeline in place to make it real. Right?
Yeah.
So again, another good example of stuff we've talked about in lots of other contexts all coming together to make this new model possible.
Yeah, and that's when you start thinking about things like how the people actually communicate, right? And how do they communicate as a network?
Yeah, of people, you mean?
The people.
Yeah.
Right.
Yeah. It's like why does everyone love Slack?
Yeah.
Right? Is a great example. And in fact, there's lots of cool examples. Even my own team, we use Slack obviously to talk to each other and to coordinate, but we also use Slack to control ops. The way we do delivery of our cloud services into production is we post messages to Slack that says, here's a new patch or branch that we want to go deploy, and that actually kicks off the pipeline to get that thing rolled into real production, right? Yeah. There's obviously an automated build pipeline for the code through staging, and then we're like, okay, this looks good, we want to push it to prod. That actually is like chat ops through Slack that says, hey, here's the thing, we want to push this, and that kicks off and both, anytime you go to production, there's always an automated part of the process and a human part of the process, which is the kind of approval and validation that we know we're good. So I agree. There's that kind of human communication side too.
Yeah, that is chat ops, right?
Right.
That's a real thing.
Right. And we have all the feedback coming there too. So all the running systems all post status back into channels and Slack for the team, for the people to be able to understand what's going on, what's
it's mayhem if you don't. But then you got to think through kind of the management systems that you use, right, to manage that complexity of the building out the microservices.
Yeah.
Because you can't just do it with Slack.
Right. Oh, sure.
You need like Jira, or you need,
Sure.
or something.
Yeah, it doesn't get you away from the kind of software delivery practices around issue tracking systems and source code control.
But for many customers, that's entirely new thinking, isn't it?
Yeah. I mean, they're not. Many of them are not even there yet, right?
Yeah.
That's the challenge too, I guess. Is that
no, we don't need to meet. We don't need to talk on the phone.
Right.
We can just do this through the software.
Right. I mean, the challenge is in real life, customers, microservices, as we've been talking about, kind of build on a lot of the trends and evolution of the last 5 years. But a lot of the clients are still on the stuff from 7 years ago. They haven't even gotten that adopted yet.
Mm-hmm.
And now you have this new thing that requires you to be good at kind of everything major that's happened in the last 5 years to kind of get you to that point.
Which brings you back to the importance of standardization,
Yeah.
right? And being able to ensure that you don't have to do it again and again and again
Right.
and again.
Yeah, I think there's like a democratization of microservices that has to happen. That's kind of underway. It says like the initial wave of adoption was all very high skill, bleeding edge kind of organizations who figured out all these problems themselves and didn't have maybe some of the legacy process to deal with. And the next round has to be, well, how do you take those ideas and deliver them in a way that a broader slice of the industry can adopt and consume the benefits of them? Right? That's going to take some work.
So I guess in conclusion, I just wanted to ask you how you think Docker and the container ecosystem have symbolically shifted our thinking about microservices.
I think maybe the biggest thing is they've just fueled the notion that there is a way to package and deliver these services, regardless of the technology choices that were made, in a standardized way that can be stood up quickly and rapidly. Like that just most basic notion of Docker that, it's a standardized package for delivery is like the step one enabler you need to make microservices real. And that's why I think, containers and microservices aren't the same thing, but they're often used in the same sentence, right? And I think that's part of the reason why. It's just like, if I wanted to do this, I'd have to start somewhere like that. I need some way to do this.
I never thought about it, but then that makes it easier to think about communications networks and makes you think about, because if everything's packaged there and you're ready to go with it,
right.
You already start building things, now you can start talking about it, right?
Right.
Now you can start thinking about how to do the issue management.
Yeah, I can talk about that thing.
Yeah.
And kind of start to ignore what's inside the box a lot.
Yeah.
And solve the problems with this kind of generic. And it's like the same thing with the service description I gave you. Like if you can define a box and say, the inside doesn't need to know about the outside and vice versa, then it's actually much easier to tackle these problems.
Yeah.
And I think containers have helped with that.
Yeah, you know what to talk about next, right? Or yeah. Well, Jason, thank you very much for taking the time to talk. It's been
great.
very interesting.
Good, thanks.